Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on graph theory, lecture number 38, in which I will discuss on Kuratowski's two graphs. There are two types of Kuratowski's graph. Number one, complete graph with 5 vertices, K5. Number two, complete bipartite graph, K33. K5 is called the first Kuratowski's graph and K33 is called second graph of Kuratowski's. K5 is the non-planar graph with smallest number of vertices and K33 is the non-planar graph with smallest number of edges. The pictures of K5 and K33 are as follow. Here in K5 we see that number of vertices are 5, V1, V2, V3, V4, V5. The graph K33 is called utility graph. Utility graph in the sense that vertices are houses H1, H2, H3 here, and these vertices are necessary things: water, gas and electricity. We have 6 number of vertices and 9 edges. Each house is connected with water, gas and electricity. These are necessary things. H1 is connected with W, G and E. The house H2 is connected with water, gas and electricity, and house 3 is also connected with water, gas and electricity. So this graph is known as utility graph. These two graphs, K5 and K33, both are simplest non-planar graphs. We shall examine that these are non-planar graphs one by one. Now we shall show that K5 is non-planar. Let V equal to number of vertices. E equal to number of edges and R equal to number of regions. Here V, number of vertices, equal to 5. E, number of edges, equal to, here each vertex is connected with remaining 4 vertices with 4 edges. So number of edges will be 5 multiplied by 4 by 2 means 10. That this is number 1, this is number 2. Now 3V minus 6 equal to 3 multiplied by 5 minus 6. 15 minus 6 is 9. This is number 3. Here we see that 10 is not less than 9. 10 means E not less than 3V minus 6. 9 is 3V minus 6. This is number 4. We know that for a planar graph, E less than equal to 3V minus 6. This is number 5. Here we see that 4 and 5 contradict with each other. Here 4 and 5 contradict with each other. Therefore, K5 is not a planar graph. Proved. Now, we shall show that the graph K33, that is complete bipartite graph K33, satisfies the formula E less than equal to 3V minus 6, but it is not planar. Since for K33 number of vertices V equal to here 1, 2, 3, 4, 5, 6. Number of edges E equal to here 3, here 3, here 3, 9 edges. Therefore, 3V minus 6 equal to 3 multiply V equal to 6 minus 6, 18 minus 6 equal to 12. Since 9 less than 12 implies that 9 is E, less than 12 is 3V minus 6. Therefore, this relation satisfies the formula E less than equal to 3V minus 6. But we shall show that K33 is not planar. Since for a planar graph, we know that E less than equal to 3V minus 6. But if a graph fulfills this relation E less than equal to 3V minus 6, then it is not hard and fast rule that the graph will be planar. So, for a planar graph, E less than equal to 3V minus 6, but for a graph which fulfills E less than equal to 3V minus 6, need not be planar. So, this is the necessary condition for a planar graph, but not sufficient. That is, converse may not be true. Number 2, we shall show that K3 theory is a non-planar graph. Let V equal to number of vertices, E equal to number of edges, and R equal to number of regions. Therefore, for K3 number of vertices equal to 6, number of edges equal to 9. Here we see that number of vertices, this number 1, number 2, number 3, number 4, number 5, number 6. Number of vertices 6 and number of edges 3, 3, 6, 3, 9. Since in K3 we see that each close walk has at least 4 edges. Here, if we start from H1, then we may go to E, and then we may go to H3, then we may go to W, then return back to H1. 4 edges. In each close walk, at least 4 edges are necessary. And degree of the region is the length of the close walk. Therefore, sum of degrees of regions will be at least since number of regions is R and degree of each region is at least 4. So sum of degrees of regions will be at least 4R. Since number of edges equal to E, therefore total sum of degree of regions equal to 2E. Let this is number 1, this is number 2, this is number 3, and this is number 4. Therefore, from 3 and 4, in theory, we get that sum of degrees of regions be at least 4R. And here, sum of degrees of regions be 2E. We get 4R less than equal to 2E. Implies that R is less than equal to E by 2. This is number 5. Since for a planar graph, by Euler's formula, V minus E plus R equal to 2 implies that V minus E and R is less than equal to E by 2. In place of R, if we write E by 2, then this side will be greater than equal to 2. Implies that V minus E by 2 greater than equal to 2 implies that 2V minus E greater than equal to 4. Putting the value of V and E, V is 6. 2 multiply 6 minus E is 9 greater than equal to 4 implies that 12 minus 9, this theory greater than equal to 4, which is wrong. Since we have used the Euler's formula, Euler's formula is meant for planar graph, and we have got the wrong result. Therefore, K3 theory is not a planar graph. Hence, K3 theory is a non-planar graph. Proved. Now we solve a problem. Problem is that so that the following figures are planar. Here, this is the figure of graph G1 and this is the figure of graph G2. Here we have vertices V1, V2, V3, V4, V5, V6. And in the second figure, vertices are A, B, C, D, E, F. The planar representation of graph G1 is as follows. Here we may write V3, V4, V5, V6, and here we have V1. Here we connect V1 with V5, and here we write V2. We connect V3, V2. We connect V4, V2. We connect V5, V2. We connect V6, V2. And we get planar representation of graph G1. Now we represent the graph G2. The planar representation of graph G2 is as follow. Here we write C vertex, D vertex, E vertex, F vertex. Here C is connected with A, D is connected with A, E is connected with A, and F is connected with A. Now, C is connected with B, D is connected with B, E is connected with B, and F is connected with B. And this is the planar representation of graph G2. In this figure, we have seen that no two edges have intersect except at vertices. Here also same. No two edges have intersect except at vertices. So these two graphs are planar representations of graph G1 and G2 respectively. Now we solve the next problem. Problem is so that a complete bipartite graph KMN is planar if M or N is less than or equal to 2. Now we solve this. Firstly, we draw complete bipartite graph. K1n and K2n. Here we write one vertex V, and here we take V1, V2, Vn. We connect this vertex V with V1, V2, Vn. This is graph K1n. And now we draw the complete bipartite graph K2n. Here we take two vertices V1 and V2, and this side we take n vertices W1, W2, Wn. We connect V1 with W1, W2, Wn, and also connect V2 with W1, W2, Wn. This is graph K2n. Since in graph K1n we see that no two edges have intersect except at vertices. So K1n is a planar graph. The planar representation of K2n is as follow. Here we write V1. Here we write W1, W2, Wn. We connect V1 with W1, W2, Wn. Here we write V2. We connect V2 with W1, W2, with Wn. And this is planar representation of K2n. Therefore, this graph is planar. Since the second graph of Kuratowski, that is K33, is non-planar. Therefore, if mn both greater than equal to 3, then Kmn is non-planar. Therefore, we conclude that Kmn is planar if m or n is less than or equal to 2. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.